This lesson is on prime factorization and exponents, lesson 1. So this is unit 1, section 1, or lesson 1 of Foundations in Pre-Cal 10. So we're going to look at prime factorizations of whole numbers and some applications of that, including finding the greatest common factor, least common multiple, square root, cube root, and we're going to look at some exponent things. We're going to start off though with factors. So factor is actually hard to define. A whole number, a factor is what you multiply together to get a number. So the factors of 6 are 1, 2, 3, and 6 because you can multiply 1 times 6 to get 6 or 2 times 3 to get 6. So those are all factors. And 6 has 4 factors. So first example here, we're going to say how many factors each of these numbers has. And I need a pen. Okay, so the number 1 has 1 factor, and that factor is just 1 because 1 times 1 is 1. The number 2 has 2 factors because the numbers 1 and 2. 1 times 2 gives you 2. Fact that number 3 has 2 factors as well. Those are 1 and 3. The number 4 has 3 factors, 1, 2, and 4, because you can do 1 times 4 or 2 times 2 to get 4. And 12 has 6 factors because you can have 1, 2, 3, 4, 6, and 12. 1 times 12, 2 times 6, 3 times 4. Those all make 12. And those are the only things you can multiply to get 12. So we're going to read a little bit about factor pairs, and a factor pair is simply two whole numbers that if you multiply together, they get the product you're looking for. So one factor pair of 6 is 2 and 3, and the other one is 1 and 6. We can do a diagram to list all the factors of a number to find them, and you might have seen diagrams like this one here in elementary school or middle school, but there's a better strategy. I'm just going to write this here. Here's a better strategy. And that is to actually list them as factor pairs. And by that I mean if I'm looking for, I'm going to factor 64. So I start off with 1 and I go, okay, 1 times 64 equals 64. So 1 and 64 is a factor pair. I go to the next number after 1, which is of course 2. Okay, well 2 times 32 gives me 64. And then I do 3. 3 doesn't work. There's no whole number that I can multiply 3 times to get 64, so I just put a line through it. But I write the 3 down because then I know that I've looked at it and it doesn't work. And this way I can systematically find all of the factors of 64 or whatever number I'm trying to factor. Okay, so I can look at 4. Well, 4 times 16 is 64. 5 doesn't work. There's nothing. 64 doesn't divide evenly by 5. 6 doesn't work. 7 doesn't work. 8 is 8 times 8. Gives me 64. And I'm going to stop here because now that I've reached a point where I've reached the square root. Oh, it didn't change colors. I wanted to change colors. So stop at the square root, actually. We're going to talk more about square roots, but I'm assuming you know that the square root is whatever you multiply by itself to get the number you're after. So once I've got to 8, I'm going to stop because the next number would be 9. 9's not going to work, 10's not going to work. The next number that's going to work is actually 16, and I already have 16. And then the next number is 32, and the next number is 64. So I've already got those, so I can stop when I get to the midpoint or the square root. Okay. All right. Example 2, list the factors of the following and determine the factor pairs for each. Well, I'm going to do those at the same time. Okay, because I'm going to use my table strategy here. So 15, I can go 1 times 15. 2 doesn't work. 3 times 5. The next one would be 4. 4 doesn't work. My next number would be 5. So I'm done. It's just 1, 15, and 3, 5. And if I were to list my factors, it would go 1, 3, 5, 15. There you go. 16, same, do the same thing again. 1, 16, 2, 8, 3 doesn't work. 4 gives me 4. So my list of factors, and then the next would be 5, and I've already hit the square root. So I've got 1, 2, 4, 8, 16, and that's all of the factors. Okay, being able to write them in factor pairs, as I've done up here on the left, that's actually going to be really important later in this course. So it's a good strategy to be practicing now. Okay. Next page. Prime and composite numbers. A prime number is a whole number which has exactly 2 distinct factors. One of them is always 1 and the other is the number itself. So the number 3 has got 2 factors, 1 and 3. Those are the only things you can multiply to get that. Composite number has more than 2 factors. It's got 1 itself and something else. And number 1 is actually neither prime nor composite because it has exactly 1 factor. And in this course, we're going to define 0 as having no factors. And we're talking about whole numbers, so we're only talking about whole numbers are greater than 0, so no negatives. And the list of first 10 prime numbers would be worth you memorizing. These are good numbers to know. 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. And I do have another video on the sieve of Eratosthenes. I don't think I say that right. And that is how to find all of the prime numbers up to whatever number you're looking for. I do an example with up to 100 because it's good to know the primes up to 100. So you can take a few minutes and watch that video. All right, classify the following whole numbers as prime or composite. Well, 46, I know that that is a multiple of 2, so that has to be composite. 37, I can't divide that by anything except 1 and 37. That is prime. 39 divides by 3, so it's composite. And 101 and 103 are both prime, and those are probably just, well, you could try everything up to 10 or 11, and they're not going to work. So you're done. Okay, they're prime. Let's talk about prime factors. Prime factors of a whole number are those factors which are prime. So in this example, we know that the factors of 6 are 1, 2, 3, and 6. And the only prime numbers in there are 2 and 3. So those are the prime factors. So an example, the factors of 12. If we come over here where there's a little bit more room and figure them out, we've got 1 and 12. 1 times 12, we've got 2 times 6, we've got 3 times 4. The next number would be 4. We're done. So the factors of 12 are 1, 2, 3, 4, 6, and 12. And then it asks, which are the prime factors of 12? So I can look at this list and I can go, well, 2 and 3 are the prime factors, 2 and 3. Now, when we express 12 as a product of prime factors, it means we're just going to use these prime factors to multiply them together in some combination to get 12. And that combination is going to be, it's 2 times 2 times 3, which I can also write as 12 equals 2 squared times 3. And this is what we call exponential form. Okay, so that's the end of this first video. You can go and complete assignment questions 1 to 9 and then come back and watch the part B. Bye.